Michael, what's today's audio topic?
Today we're reviewing Topping's DA converter, the D900.
You've been really into DA converters lately, huh? Master, you want to hear about Topping's D900 too, right?
Yes, I want to hear.
What kind of DAC is the D900? Delta Sigma or R2R?
The D900 isn't either Delta Sigma or R2R.
Huh? Aren't DAC types either Delta Sigma or R2R?
The D900 is Topping's discrete DAC, but it uses PSRM technology instead of Delta Sigma or R2R.
PSRM technology?
PSRM stands for Pure Signal Reference Module. It's a proprietary 1-bit discrete DAC architecture developed to overcome the limitations of conventional DAC chips. Simply put, it's a technology that operates a massive number of ultra-precise switches in parallel to suppress noise to the absolute limit. Let's dig deeper into how it works. Conventional DACs, like those from ESS or AKM, pack all the circuitry into a tiny silicon chip. In contrast, PSRM builds the DAC circuit by arranging generic ICs and resistors on a PCB.
Aren't other discrete R2R DACs built similarly? Is PSRM different from the R2R approach?
R2R is multi-bit processing, while PSRM processes signals in 1-bit increments.
Multi-bit? 1-bit?
As we discussed before, DA conversion uses either the R2R method or the Delta Sigma method. R2R is multi-bit processing. Delta Sigma is single-bit processing. Let me explain their characteristics. First, the multi-bit DAC, R2R method. Multi-bit processing is an intuitive conversion method, like building a staircase one step at a time. The principle is to output a voltage directly corresponding to the number of bits in the input digital data. For example, with 16 bits, it uses 16 resistor ladders, R2R ladder, and adds voltages according to each bit's on, OFF state. For each bit of data, it passes through a precise resistor corresponding to that bit's weight and outputs the summed voltage. The advantage is that the conversion process is extremely simple and relatively tolerant of timing accuracy, jitter. The disadvantage is that it demands high precision resistors. To reproduce the minute voltage differences of 16-bit or 24-bit resolution, ultra-precise resistors with tolerances below 0.001% are required, causing costs to skyrocket. Next, the 1-bit DAC, Delta Sigma method. 1-bit processing is the modern mainstream method, akin to adjusting brightness through rapid flashing. The principle involves drastically reducing the number of bits to just 1 and compensating by massively increasing the sampling frequency over sampling. It uses Delta Sigma modulation, rapidly repeating the change, delta, and accumulation, sigma, of data, expressing sound volume through variations in the density of 0 and 1. Noise shaping pushes the massive noise generated by 1-bit conversion into the ultra-high frequencies inaudible to the human ear. Finally, a low-pass filter cuts the high-frequency noise, leaving a smooth analog waveform. The advantage is that it doesn't rely on resistor precision, enabling high resolution at low cost. Over 90% of modern DAC chips use this method. The disadvantage is that the digital processing is complex, and it's said to be prone to producing a digital harshness due to the calculations.
PSRM is the same as the Delta Sigma method for 1-bit processing, right?
It's a bit different from the typical Delta Sigma method. PSRM uses 1-bit processing like the Delta Sigma method, but it doesn't use a DAC chip. It uses a parallel configuration of numerous discrete 1-bit elements, matrix-controlled to generate the analog waveform. The PSRM in the D900 utilizes the smoothness and linearity of the 1-bit method. However, by building the circuit with discrete components instead of an IC chip, it achieves this sense of energy from the sheer volume of components characteristic of multi-bit devices.
I see. So it takes the best aspects of both R2R and Delta Sigma methods.
Exactly. To put PSRM simply, it's a brilliant design that says, run the transparency of a 1-bit method through a luxurious, multi-bit grade circuit.
Sounds a bit over the top, but it must sound great.
Hearing the D900 sound was a shock to me. It made me wonder what all the previous DACs were even about.
That impressive? By the way, what's the price for the D900?
The D900 is priced at $1,799. Now, let's start with the front panel. The front panel features only a small display and knobs for volume and various settings. It's a clean, minimalist design.
So no headphone jack?
The D900 allows volume adjustment, but it doesn't have a headphone jack. They've streamlined the features. You can choose from 3 display modes: volume or frequency display, VU meter, or FFT display.
FFT display?
It's a level meter showing sound intensity per frequency. Now, let's move to the rear panel. From left to right, XLR pre-out, XLR line out. The D900 doesn't have RCA outputs.
Huh? It has two XLRs but no RCA?
By omitting the RCA circuitry and focusing solely on XLR, they've likely improved sound quality.
Why does it have two XLRs?
Probably to bypass the volume circuit. Many devices allow bypassing the volume circuit, but only have one terminal. But the D900 has separate XLR terminals for the preamp output and line output. I suspect the line output is designed to bypass the volume circuit.
I see.
The digital inputs are extremely comprehensive. I2S, AES, 2x coaxial, 2x optical, USB-B, USB-C, and Bluetooth. I've never used a DAC with this many digital inputs.
That's an impressive number of digital inputs. Won't it take too long to choose one with so many?
The remote has 2 buttons to memorize input settings. So, if you have up to 2 types of inputs, you can change the input terminal with just 1 button.
They really thought about usability.
Plus, you can set it to power on automatically when it receives a signal. However, it only powers on. It doesn't change the input selector. Then there's the 12 volts trigger terminal and the power switch. The included accessories are the remote, USB cable, Bluetooth antenna, and power cable. The remote is made of aluminum alloy and feels really high quality. You can tell it's a mid-range DAC.
What kind of features does it have?
It has PQ settings. That stands for parametric equalizer, and you can choose from 5 presets or 5 custom settings. Personally, I prefer the sound clearer with PQ off. You can also choose volume increments of 0.5 dB or 1 dB. The volume control is an attenuator type with audible clicks.
How did the D900 sound?
As Topping's flagship discrete DAC, its sound quality is outstanding. It's incredibly high resolution, yet retains a beautiful sheen in the highs. I thought those were contradictory, but it achieves both at a high level. The left-right separation is also superb. Sounds coming from the left and right are cleanly separated. So the imaging is spot on. Vocals sound right in the center. This is incredibly comfortable. The low-end punch is also impeccable. I've used many DACs, but I've never heard sound like this before. Discrete DACs allow manufacturers to create their own sound signature, but I never imagined it could be this good.
Michael, you were really gushing. By the way, did the sound change between the pre-out and line-out outputs?
The line-out output, which bypasses the volume circuit, sounded clearer. Switching to the pre-out output caused a slight muddiness in the sound.
I see. How does it compare to the DACs you've used before?
Compared to the DACs I've used before.
Guys, closing time is approaching.
Whoa, is it that late already? Next time, let's hear how the D900 compares to other DACs.
If you enjoyed this video, please give it a thumbs up and subscribe to the channel.